So with the transmission out of the Corvette, we're ready to move on to the next step. And this next step is probably one of the more intimidating steps of the process. We need to make sure that the bell housing is centered to the crankshaft. And to do so, there's measurements and calculations that we need to do to make sure that this is done correctly. And in the instructions that we were sent from American Powertrain, it's specific in saying that failure to do so will cause transmission failure and damage. So Matt's been playing around with it a little bit to make sure he's going in the right direction, but we're going to now record and follow along as he makes these measurements and calculations to make sure that it is installed correctly.
So the first step that we need to do to get this bell housing on is put the flywheel on right here. So we're going to take some emery cloth and we're going to clean up the back of the crankshaft to try to see if we can get this to slide on. The tolerance from the flywheel to the crankshaft is really tight. I want to make sure it's nice and clean so it goes on as straight as we can. You may have to heat it up, slip it over it. There we go, we got all the light rust cleaned off. And it looks ready to go, so I'll grab the flywheel. I want to align the off-centered hole with the off-centered hole. Okay. So now the next step is putting the bolts in and torquing them. It says to use blue Loctite, and we got ARP bolts, so some blue Loctite, ARP stuff on the heads, and torque them to 75 pound-feet. And the torque spec 75 foot-pounds. Let's see what happens. The next step is to install the bell housing with 4 bolts, and then we're going to put the dial indicator in. See what we have. This is the dial indicator that I have. It's got a magnetic base. I'm gonna stick that on the back of the crankshaft, and then we're gonna center this at the 12 o'clock position right here, and then go around and take some measurements. So we're gonna 0 it right there, and then we got 0 and 6, 12 and 6 and 9 and 3. So we'll rotate it and then see how much the dial indicator moves and then make some marks and see what we got. This is what I got last time when I tried it. Tell me when we're about here.
Okay. A little bit more. Okay.
So we just went positive from 0, so we're at 6 thousandths. There. Now we're going to rotate to here and see what we get.
Just a little bit more. Right there.
0.016. And now we're going to go to the next one. And there we have 9 thousandths. More like 8.075, but we'll just say 009. That's close enough. So now we go back to the top, and if it reads 0 once we get there, then that means that nothing moved and our calculation should be correct. Yeah, it's perfectly at 0. So that means that the dial indicator hasn't moved. If it wasn't at 0, then you just reset it and start over. So now we need to take the calculations, which is basically dividing it by 2. So, and the spec is 0.004 of tolerance. That's out this way or this way, vertical and horizontal. So we have 16 thousandths this way. So that makes us 8 thousandths out. We need to move the bell housing up about 8 thousandths. And then this side, we're only about, 3 thousandths out this way. So that's spec because, we're fine there because spec's 004. So I did order some off-centered dowels, and they're right here. So these are 7 thousandths off-centered. So now we're going to take the bell housing off. We're going to knock out these pins somehow, and then install these and try to figure out how to get this thing perfect. This is the alignment pin that we're talking about that we need to change. And they're just pressed into the block. So there's a variety of ways to get them out. I hope they're not that stuck. We're just going to try a hammer and a punch from the back side and try to persuade it out of there. And if that doesn't work, we'll try something else. But now this side. It's got a little more stuff in the way. So we take on all of our measurements, and now these parallel parts apparently are what make it go up and down. So we want to go up. And then you tighten the Allen wrench once you get it all set. Okay. Well, that's 15 thousandths. It shifted it a lot. 14 pounds. That's strange. I wasn't expecting that. 20 thousandths. Some of this is going terrible. This is not what you want to do.
A tiny bit. Okay.
11 thousandths. Oh, it's 14. So we took our measurements and it looks like I put the dowel pins facing the wrong direction. So I'm going to loosen up, take these bolts back out, turn these 180, and then we'll check it again and see what happens. We're back to 0. Okay, that's the best it's ever been. That's cool. So let's do the math on our our horizontal axis runout. So the maximum acceptable tolerance is 5 thousandths. So I crunched the numbers and it's perfect right here. So we have negative 002 on this side and positive 004 on this side. So you add them together, which is 6 thousandths difference, divided by 2, which comes out to 3 thousandths, and the amount of maximum tolerance is 5 thousandths. So we're right on the money there. And then we're 0 here and 001 down here positive. So add them together, divided by 2, we're 0.0005 out, which is perfect. So now we can tighten up these Allens right here. I don't know if you can see them, but there's little Allen wrench, little Allens in these dowels, and you tighten those up, and then that widens inside of the block, and then that'll keep that from rotating, so you don't have to mess with that anymore. So the instructions that came from the manufacturer on this say to tighten these to 9 pound-feet. You just barely feel it click. There we go. So that's permanent. All right. Awesome. I'm excited. Let's keep going.